I opened my harmonic mount and found that this deck shell here, which is just 3D printed plastic, was doing work as a structural component, holding the deck axis and the saddle and your telescope to the RA axis with 6 small bolts that were just being squeezed through this 3D printed shell. So I'm doing something that I've never done on this channel before, and I haven't done in my personal life in a while. I'm going to use drafting in CAD to make a new part for this. And using the sponsor of this series, PCBWay, we're gonna have it manufactured out of aluminum. And we can have it manufactured out of any material we want. They actually do a lot of different materials, and we'll talk about that in a minute. But we're gonna start with an aluminum replacement shell for the TeSeek Mini 11. This is the kickoff of that series. There's no hype here. I'm gonna walk you through how I sort of got all the critical dimensions, how I made the file in CAD, and how I submitted the file through PCBWay's online portal so that I can get the first iteration of this in my hands and we can start testing it. Hi, I'm Francisco. Welcome to Deep SkyLabs. I'm an amateur astrophotographer, and apparently now I'm also an amateur manufacturing engineer who's trying to build parts to make our equipment even better. If you watched the last video on the TeSeek Mini 11, you'll see I actually really like this mount. I just have been using it for a while now. I've taken it on a couple small adventures, and I really don't trust this deck housing here, especially now that I've seen the insides and I know how this is all held together. Now, to be clear, the tracking on this is already pretty good, and I don't necessarily know. We'll test it to see if there'll be any improvement. But really, I just want to, get rid of any of this flex that exists between the deck housing and the RA. The rest of this housing here, the way it attaches to the wedge, is actually pretty good, and we may upgrade this in the future, but for now, I want to focus on what I feel is the weakest part. To be clear, I'm basically redesigning the deck shell and housing. So it's this half of the mount here that holds eventually the saddle and your telescope. Once I'm through the prototype iterations and I'm confident that this file works, I will make the file available so that other people like yourself can order it directly from PCBWay in metal if you want to. And here's why I'm focusing on the deck axis first. The RA motor and housing on this side actually seem pretty solid. It's a pretty decent sized chunk, and it's pretty tightly pressed in there. This feels like the grown-up part of the mount, excluding this sort of flimsy housing for the electronics. I have my own issues with that. But for right now, the deck side is the thing that makes me nervous. On this mount, the deck housing is holding the entire scope through the 6 small bolts that you can see on the inside right here. These bolts hold this casing here to the rest of the mount. So that means that this deck housing is not cosmetic. It is part of the integral structure of this mount. And the question that I want to answer with this series is, if we strengthen this, if we make this part out of metal, does the mount feel better? Do we improve the general feel? Is there less flex? Do I feel more confident putting on a very expensive piece of glass on there? And potentially, can we improve the tracking behavior? Because that load might be or will be held a lot more rigidly. We're going to test that. So this series is going to be iterative, which is how real product development works. Somebody doesn't just sketch something out and then boom, that's what you buy. So we're going to do the measurement, which I do in essentially drafting on paper, which is how you know that I'm an old man. And then we're going to transfer that into CAD. We're going to submit that file to the sponsor of this series, PCBWay. Once I get that back from them, they have about a week and a half turnaround time. We'll do a fit test and clearance test. We'll do a load test on the mount. And then we'll do some real sky tests with slewing and guiding. And then, based on what we learn from that, we might iterate to a second or third prototype if needed. And that's not really failure. That just means that we learned something we didn't know. Only then, once we've gotten through whatever iterations we need to get through, and I feel like it is an upgrade, then I'll be releasing the files to everyone so you can get them online. I will not be, just putting a file online after version 1 because I don't want anyone bolting an unproven part to their mount and have that cause any damage to their equipment. And I'll probably be releasing 2 versions. One is essentially a duplicate of the current housing as it exists today, so that if you have a really nice 3D printer, you can print yourself replacements. And the other will be the CNC optimized file. So let's get into it. When I measure parts like this, I like to sketch everything on paper first. It sounds old school, but it helps a ton because I break the whole thing down into faces and it's easier for me to just erase and sketch on paper versus doing it in CAD CAM. This is how you can tell that I'm a little bit old. I'm basically asking, what are the important flat surfaces? Where are the holes relative to those faces? What surfaces locate, the motor and the bracket and the connection to the RA axis? Once the part is broken down by faces, the CAD process actually becomes easier because essentially CAD is you sketch a face, you extrude, you create a 3-dimensional part, you create a new sketch on that face that you just created, and you repeat. And I'm not just measuring the obvious stuff, bolt spacing is obviously important, but so are things like wall thickness, clearances around the motor, if there's any wiring concerns, and anything that might collide when you assemble it. Because if there's one thing I've learned from opening the mount, tiny clearances can turn into really big problems, as you remember from that video. For me, I had to install Autodesk Fusion. For personal, non-commercial use, Autodesk offers a free personal license with some limitations, but it is perfect for hobbyist projects like this. And I'm not going to pretend I'm some CAD wizard. I haven't used CAD in about a year, and even then it was for very small, very simple parts. So I did have to shake off the rust. Here's the good news, though. For parts like this, something like Fusion is pretty simple. There are a ton of different CAD softwares available that are free for hobbyist use, so find the one you're most comfortable with. For me, my workflow is start with the initial sketch to create the general shape, extrude that into a body, and then create new sketches on those new faces, cut holes, add bosses, add pockets, and then repeat until the part matches reality. This part isn't necessarily complicated, but what takes time is being careful and thinking like a manufacturer. Because I'm not just designing a part that looks right, I'm designing a part that can actually be CNC machined reliably. Now that's one of the advantages of the way this part was made before. It was 3D printed. So any internal complexity to the structure didn't matter because you were 3D printing it layer by layer anyway. But as we move over to CNC, we have to make changes specifically to make that manufacturing easier, like avoiding impossibly sharp internal corners, making fillets where a tool needs to fit, making sure that the features are reachable with standard tooling, and generally designing it so that PCBWay doesn't hate me for submitting this file for them to manufacture. Quick sponsor moment, this series is going to be sponsored by PCBWay, and part of my deal is to give them some real airtime because honestly, they're enabling this entire project. PCBWay started as a PCB prototyping company, and they've been doing this for more than a decade, focusing on fast turnarounds for makers and engineers. But what's cool now is they're basically a one-stop manufacturing shop. They don't just do PCBs and assembly, but they also do CNC machining, 3D printing, sheet metal, and they'll even do injection molding, which is a really crazy thing. And the workflow is exactly what us hobbyists need. You upload your CAD file, they review it, you get a quote, and a manufacturable solution without having to personally know any machine shops. And that's a big deal, because a few years ago, making one-off custom parts like this properly could have been either impossibly expensive or just totally inaccessible if there wasn't a small machine shop in your area that you could reach out to. So big thanks to PCBWay for sponsoring the series and helping turn CAD on my laptop into a real prototype, making this amazingly tiny mount even better. So I submitted my redesigned deck housing for prototype. And again, here's the mindset. Prototype 1 is not the final product. Prototype 1 is first contact of my idea with reality. I expect to learn things like, do my bolt holes align perfectly? Is there any interference with the motor or the wiring harness? Are my tolerances too tight or too loose? And does it clamp on to the axes the way that I expect it to? And this is where iteration starts. And here's my test plan that I hope to do on camera and have you guys see every step of the way. So we'll start when I get the part in, which hopefully will be in about a week or so. Does it bolt, do all the parts that need to be in there bolt in cleanly with zero forcing? I don't want to force anything into this. Do the threads align correctly the first time? So you've got those long bolts that go down from the top and they attach to the deck motor. Does all of that line up correctly? And then we'll do a clearance and motion test. Does anything rub or bind when we're trying to move everything? Does it clear any of the cables that need to be cleared? And does any part of it interact in a way that we weren't expecting? Then we'll do a static load test. I want to sort of assemble the mount as a fully dressed astrophotography rig, and then check for flex and shifting or weird creaking under load. I want to do that before and after the upgrade, as I'm pretty sure there is a measurable amount of flex between the deck housing and the RA housing itself. And so I want to measure that once we get the new parts in, before and after. Then we're going to do some slew tests. We're going to start slow. We're going to, slew the mount around all of its normal sort of positions that we would expect it to be able to do. We're going to confirm that there isn't some new collision zone that might not have been there before. And then we're going to do normal slews. And then I'm going to do a real sky test, which is probably the most important for me. We're going to do the same target, same workflow, same guide settings as for the 3D printed and the CNC part. And we're going to compare guiding behavior as well as sort of overall feel during tracking. Sometimes you'll notice, it may look, the number may say that you've got, X amount of arc seconds of error, but you can see sometimes in the pattern of the guiding corrections that weird things happen. And I want to see, is there any difference between the CNC metal part and the 3D printed part? If it doesn't pass any of those stages, we don't pretend it's fine, we iterate. Or as long as it does as good as the 3D printed part in all of these arenas, then we can continue to move forward. Once the file design works and we've got a prototype that I feel passes all of our checks, I will make the file available to all of you to order it as well. And I think there'll be two versions of this. There'll be the file version that is essentially a duplicate of the existing part, which means you might be able to manufacture your own 3D printed housings if you have a 3D printer. And then there'll be the CNC optimized file, which is what we're going to be working on in this series. I will make both sets of those available. But I am going to try and do it responsibly. I want, clear compatibility notes, any changes to any hardware that you need to buy. We might have to tap some holes. I want to make sure you know about all of that before you get into this crazy process. Also, if you have any ideas for improvement on this part itself, please let me know. I'm thinking things like, should we be adding internal ribbing to make the part even stiffer? Where do you think that all the stress concentrates on a part like this? Or should we try and make sort of a maker-friendly upgrade kit where, maybe we do this, we do the deck housing, we do the electronics control box as well in the future. What do you guys want to see us work on? The next episode in this series will happen once the prototype arrives. At that point, we'll do an unboxing of the manufactured part. We'll test fit it on the mount. We'll put all of it together. We'll do those alignments and clearance checks like I mentioned. We'll take it under the night sky. I'm actually going to probably try and do a trap, like go out somewhere to do some photography because I think it's going to be cloudy here for the next couple weeks. So we'll need to use this travel mount in the way that I believe it's intended to be used, and we'll actually travel somewhere to see if we can get some good images. This is the kickoff for designing your own astro gear. I think this might end up being a series here on Deep SkyLab. I've got ideas, and you guys have some really good ideas on other things that we can design to make parts either more modern or better. And if you want to see this series continue, make sure you get subscribed. I do track sort of subscriber counts per video to see what gets people most excited. And so if you want to see a series about us making our own parts for astrophotography, make sure you get subscribed on this video or drop a comment down in the description below. If you want to support Deep SkyLab more directly, you can join the membership, which will give you access to probably some of these videos a couple days early, as well as access to a lot of raw data that we'll be sort of building, and maybe even some STL and step files that I might not make more generally available. I will make sure to make available to the members. So this is all really exciting. And again, huge thank you to PCBWay for helping me take on this project, which I don't know that I would have thought was possible even just a couple months ago. For Deep Sky Labs, I'm Francisco. Clear skies.